Hi, welcome to Ronnie's Corner. Some of you have asked me, how do you actually solve for the optimal consumption of the poor consumer that we've been talking about? Because in the lectures we saw drawings, graphically we saw that the indifference curve have to be tangent to the budget line, but how do we actually do that? So here it goes. So consider the following tale of two people. So they both have £10 to spend. They can buy products X or Y, and let's suppose just that the prices are actually the same. But they're different. Okay, let's call one U and one V, and the U person has a utility which is given by UXY is equal X to the power of a half times Y to the power of a half. And the person called V has a different utility function. Their utility function is X to the power of an eighth, Y to the power of 7/8. You see that the person called U kind of treats X and Y symmetrically. So that means they kind of like X, Y to the same degree. And in some sense, X and Y, could be, they can substitute X and Y, they can flip X and Y, and they would have the same utility. Whereas person V kind of likes Y more, because Y has a higher power than does X. And, we might expect, before going into this, and this is like a good point, I think, when you think about exams and stuff, just to have a conjecture what would happen. We would kind of think that person V would tend to buy optimally more Y than person U. Okay, so let's see how that pans out. Let's first focus on person U. Now first let's try to think about their indifference curves. So the way I'm going to draw, basically I'm going to draw them. The way I'm going to think about indifference curves, remember indifference curves are lines, they're consumption bundles, XY, such that they give the same utility. So they can get the same utility when they consume different levels of X and Y. So if you connect all the points XY that give the same utility, in this case 3, you would get the indifference curve for a level of utility of 3. We can do the same for 2, level of utility of 2, and we can do the same for 1. So how does the picture look? So this is the picture for person U. Note that these indifference curves look nice and smooth, and they're also kind of symmetric because the utility function is symmetric. Now we can do the same thing for person V, right? So we can draw all the points XY that give V the same utility 3, and then do the same for the level of utility 2, and then do the same for a level of utility 1. So how does his or her indifference curves look like? And you see they're all very nice shaped like we have in our pictures, but they seem to be skewed towards the y-axis. So this is no surprise because this person kind of puts more weight on consuming y than they do about consuming x. Now both of these people face the same budget line. The budget line is given by this equation here. 10 equals 4x plus 4y. 4 is the price of x. 4 is the price of y as well. So if you buy x units of the x product and y units of the y product, this is your total expenditure, 4x plus 4y, and this is the income you have. So if you spend all your money on x and y, these are the points that you can consume of x and y. How does it look? Well, we know that it's a line, right? And we know if you spend all your income on y, you can buy 2.5 units of y. If you spend all your income on x, you could get 2.5 units of x. So that's no surprise here. Now, but how do we actually compute the optimal consumption bundle? Okay, so let's focus on U for a minute. Here is some preliminary work we need to do when we try to solve for the optimal consumption of U. So we know that at the optimal consumption, the price ratio has to equal to the ratio of the marginal utilities. Okay, don't be afraid, but here I compute the marginal utilities. You don't have to worry about this too much. I'm not going to ask you to do this stuff in an exam situation, so just sit back and enjoy what's happening here. So px divided by py, well, we know what px and py are. They're just each 4, so px divided by py is 1. What is mux divided by muy? Okay, so here I compute. Mux is this expression here. Muy turns out to be this expression here. And when you take the ratio, you get a simple solution, y over x. Okay, so now we're ready to think about what's going to be the optimal solution. Okay, because we have two equations with two unknowns. The first equation comes from the following fact. We know that the consumer will consume on the budget line because they're rational. They like both x and y. They want more of them if they can, so they're going to spend all their money. Spending all their money means that x and y, the solution x and y, will satisfy the budget line, which is this equation here. The second equation comes from our optimal condition, which is that the exchange rate in the market, px divided by py, is equal to the exchange rate in the brain or in the preferences, which is mux divided by muy. So this gives us the equation over here of y over x is equal to 1. So now we have two equations. This is one, this is the other, with two unknowns, y and x. So we can solve that. Okay, so if we solve that, from the second equation, we get that x is equal to y. This is no surprise because this person, both prices are symmetric, x and y both cost 4, and this person treats x and y in their utility, and therefore this is not a big surprise that at the optimal solution, x would be equal to y. So what we do, we plug this into the budget constraint, and we get the following solution. The solution for you is that x is equal to y is equal to 5 over 4. Okay? Good. How does this look graphically? Well, it's on the budget line, and it's the tangency between an indifference curve and the budget line. In this case, because everything is symmetric, the prices and the utility function, we have a symmetric solution. How will this look like for V? Well, we can do the same thing for V. This is the preliminary work. The price ratio is 1, as it was before. Vx now is the derivative of V with respect to x is equal to this ugly expression. Mvy is equal to this ugly expression. And then the ratio between them becomes y over 7x. Note that this is related to the powers, right? We had 1/8 versus 7/8, so there's kind of a 1:7 ratio between y and x going on here. Again, how do we solve for the optimal consumption, right? So we have two equations. We have to be on the budget line, and we have to satisfy the optimality condition, the tangency between the budget line and the indifference curve. Okay? Solving this, we get the following. X is equal to 5 over 16, and y is 7 times as larger, 35 over 16. Again, you can plot this graphically, and you see that although prices are symmetric, the indifference curve is not symmetric, but this person prefers y to x, and therefore they're going to consume more y than they are consuming x. Excellent. So, this was just a little bit an illustration, I guess, of how these things are computed actually, and this is stuff you're going to do in year 2.